afternoon, everyone. My name is Parusha, and today I'm going to walk you through my SPR 600 threat hunting project, which I basically reproduced a real world cyber attack and build a custom detection system to catch it. So, the attack I chose called SQL brute force lead to a blue sky ransomware, documented by DFIR report in December 2023. The most striking thing about this attack is the threat actors went to initial access through the deploying ransomware across the entire network in just 32 minutes. So today I'm going to walk you through how I recreated this attack and how I built the basically host-based detection rules to catch it. And at the end I will show you the live demo which my automated Python script executes the entire 9 phases attack chain, and you will see the all the alerts fired in a real world time on my custom dashboard. So let's move on to our next slide. Yes, so what's my here is what we cover next few minutes. So first of all, I will briefly explain you the overall incident, like the original incident. So I'll show you how my lab setup with 4 machines here, 4 simulating machines, and the third one over here is detection strategy. So it's all about detection based on the pyramid of pain. Then the fourth one is here is the main event which I'll run on my live demo, where I will show you my automated Python script executes the entire attack and trigger the alert. Fifth one is I'll show you my own custom Python based dashboard which I built from scratch, and finally I'll wrap up with my work and what I learned and any questions if you have. So let's move on to the next slide. So here I'll give you a quick version of the original incident in the December 2023. What happens? So the DIFR was published with a write-up of an intrusion intrusion where the threat actors compromised an internet-facing Microsoft SQL server. So the whole attack took 32 minutes from start to finish, and here is the sequence of event basically. So attacker used Hydra to brute force, as you can see over here. So attacker used Hydra to brute force the password basically, and taking over 10,000 logging attempts before they found the correct password. So once authenticated, they enable XP underscore CMD shell, they enabled it to extended the stored procedure which let them execute the operating system commands through the SQL server they have downloaded basically. Then a Cobalt Strike beacon via PowerShell performed the network discovery and moved laterally to the domain controller using PXEXEC, and finally deployed a blue sky there ransomware, so which encrypted the file network wide and renamed them with the extension called .blue sky. And it took 32 minutes timeline in a key insight that human cannot respond fast enough because it's automated detection at every phase of the attack. So let's move on to the next slide. So to safely reproduce this attack, I build a 4 VM lab in my VMware where it's a fully isolated host only network. Nothing leaves my host machines. So on the left hand side, if you can see, I have a attacker VM running Ubuntu which simulates the adversary. Then the SQL01 over here is my Windows Server 2016, which has a Microsoft SQL Server acting as a beachhead, and this is the initial target. Then DC01 is the another Windows 2016 machine running Active Directory as a domain controller, and this is what attacker laterally moves to. And finally this is my SIEM VM, which is Ubuntu running server running Wazoo, and it collects all the security telemetry basically. So that's it. And the two servers, each of them have Wazoo agents, and a Sysmon gives me like they have a Wazoo agent and Sysmon gives me the reach endpoint telemetry, which process the creation with the command line files basically, and creating events, registry modification, and the Wazoo agents forwards all this to the SIEM over TCP at port 1514, where my custom rules evaluates every event in a real time. Then let's move on to the next slide, which is my detection strategy. So follow my methodology called Pyramid of Pain, created by David Bianco. The idea is simple. The indicators are at the bottom of the pyramid, like the hashes or IP address, are like easy for attacker to change, but the attacker can rotate their IP in second. But indicators at the top, they are like actual technique and procedure required to rewrite the attack and evade. So my custom rules delivery target the same TCP of the pyramid. Instead of matching the port number or a specific like tool name, I match like behavioral that has attacker must perform regardless of what tools they are using basically. And for example, like I have a rule that detects like whether SQL server process spawns a PowerShell or a CMD shell. So this is a parent child process relationship that structurally requires of the XP underscore CMD shell like child process basically technique. It cannot bypass without abandoning the technique entirely. So that's the kind of detection that hurts the attacker. So move on to my next slide. These are all my custom HIDS rules. So I have basically 9 rules for my 9 phases for this project, and they like live in like slash var os sec etc rules local rules like .xml on my seam, and uses the rules ID like 100 through 100 So each target, like each rule targets a specific phase of the attack and is mapped to the corresponding MITRE attack technique. So rule 100100, here as you can see over here, it catches the XP underscore CMD shell. Then rule 100101, it captures like SQL server process like tree relationship I just mentioned. Then rule 100102, it's just a like Windows Defender disable that attacker has to do this to avoid detection basically. Then 3 is for the schedule task, which like I set it up there, schedule task. Then 1004, as you can see over here, 1004 is for PowerShell based like 64 encoded. Then 105 for remote service creation, 106 for Blue Sky ransomware extension, 107 for Who Am I discovery, and 108 for my credential dumping. So that's my like that's a like smoking gun for the Blue Sky ransomware. And the severity levels on the right side you can see over here shows very serious for each detection, because level 15 is critical. As you can see over here, some has a level 15 like is a critical, and level 14 is very high, and also level 12 is high. So the level 10 is a medium, and these all map the incident response priorities basically. So move on to the next slide. So here I'm gonna now show you the live like now I'm gonna show you the main event, the live demo. So instead of running like each attack manually, which would take like 30 plus minutes, so I build an Python automated script that executes all 9 phases like from end to end in just like one command, end to end in one command. And this is going to be demonstrate how fast modern attacks really can go, because you will see the detection rule fires real time on my custom dashboard, and it's taking like the manually command was taking more than 30 minutes for the attacker to finish this attack. But my automated Python script, it's not even taking more than a minute to finish everything. So let me go to my attacker machine. So here I'm gonna start it now basically. And so here it will first ask me like basically see like the script asks for the confirmation, would you like to continue for this attack? So I will say yes, and it will start the attack for all the 9 phases. As you can see, it started the first phase, which is MySQL brute force and trying to brute force everything like see. So as you can see over here, the password is like discovered, and the password 123 like after 27 attempts. Now the it's waiting for like phase 2 basically, like enabling XP underscore CMD shell. So you can see the SQL commands executing. Now it will execute some SQL commands. see, it's done. It took it like command took it 30 seconds to finish, and it says enable successfully. And in the wazoo it fired rule 100 100. Now phase 3, like discovery commands, where it will like write who am I command, net user, net group, nl test, net view commands, and it will take some time to run. So as you can see, we are the it enabled here, and it's you can literally see here like it writes every SQL commands executing over here for phase 2. Then move on to the phase 3. It's like discovery commands, where it writes who am I, net user, net group, NLT test, and net view, everything. See here it says who am I command getting output, then writing who am I again, then here it says who am I private, it writes everything. Now move on to the phase 4, which is defense mechanism, basically disabling Windows, basically Windows Defender. So to get say disable Windows PowerShell, then executing some set my preference and disable the real-time monitoring true. Then it fixed that thing. Then again it went to see it disable everything with that permission set x my thing, and then move on to the phase 5. It creates a scheduled task for persistent. Here see it creates a scheduled task of persistent with daily 00 run system. And then move on to the next one, which is phase 6, which is PowerShell base 64 encoded commands. So executing all base 64 commands over here, see. Then move on to the phase 7, which is like dumping credential with secret dump.py file, and there are see SAM hashes over here. Let me show you the SAM hashes. Here are the hashes, and here are the hashes over here, all the hashes. And then move on to my next slide, which is the lateral movement. And it also says see same hash and cache credential and everything got extracted. It's at the top, which was our user for the SQL. Then the phase 8, which shows like the lateral movement to domain controller using the pxexec. As you can see over here, it get connected, and you can see the IP address as well, and uploaded a binary and created a service that we got as an interactive shell basically. And in the shell you can see the NT, basically the see NT authority system DC01. So that means, and finally after that we will move to our phase 9, which is blue sky ransomware like stimulation, and that renames the files with dot blue sky, like dot blue sky, as you can see over here. And after it's done, a tech chain completes, it take like 1 minute and 10 seconds, and it responded to like DIFR time to ransomware was 32 minutes because it was manual. And it says the phase result like success with the brute force. All phase 9 are like all 1 to 9 phases are success. And to check our dashboard, custom dashboard, let me copy this and show you my custom dashboard, which will have like fired rules for my everything dashboard and everything here there. It's gonna take some time to reload. Yeah. Oh yeah, so before there I need to run my dashboard script from Steam VM. So I have one more script. See, you can see my dashboard is now running and it will work now over here if I reload it. See, SPR threat hunting dashboard. See, it has 9 alert from my rules. Here are my rules fired, then my custom rule like hits and total alerts. So here it's my attack chain which has my detection system, what it detects and what it didn't detect. Then here are my alert severity level for everyone, high, medium, low. So like you can see everything over here, medium, critical and everything. Then MITRE tactics, which has a defensivation, discovery and lateral movement. Then alert per endpoint for DC01 VM, then SQL VM, and for the attacker SIEM VM. So here are my custom rules activity, how they are like alerting, and these are all my severity alerts. Basically, as you can see over here, it's gonna see the same in Vazo, but I had made my own like dashboard which will fire the recent high severity alerts, and you can see over here how simple is it working. And now move on to the slides. So let me explain like how my basically how my automation works. So just to explain over here, this is my attackchain.py file. It's like basically a script, a single Python script. Orchestra hydrates like imp packets and PowerShell commands to execute every phase. I write this way for the four reasons. Basically, it's like reproducible. I can run it anytime and get the same attack, which is essential for testing my detection rules. Second is it's fast. It can demonstrate the entire kill chain in like under like a minute. Same, instead of 30 minutes of manual typing. Then third is realistic. So modern attackers use automation. So my stimulation matches the speed of intrusion detection. And four was demoable. I can run it during the presentation with one command, so you can see the entire attack in real time basically. And move on to my next slide, which was my custom Python based dashboard, which I showed you on the browser right now. So this Python, I built it from the scratch using the Flask web server and chart.js. It runs on my like VMs and reads all the alert directly from the Vazu manager log, basically in a real time. So looking at the top, you can see over here, you will see I have collected these amounts of logs, custom hits, rule fired, and kill chain attack. So it has everything over there. And now move on to my like what I detected. So 8 of my 9 kill chain phases I caught by my HIDS rules. 5 of my 9 custom rules fired during the attack. It's during the attack, and after attack I got 8. So during attack I got 5, and like 11 different MITRE attack techniques were like detected here. And below you can see the same top firing rules, which is 100 1001, the SQL server spawning, the PowerShell rules fixing fired 16 times, as you can see over here. Like it triggers on every command executing through the XP_CMD shell. Then rule 107 here shows like caught the who am I discovery, then eight times, and then the lateral movement, defender disable, and the encoded PowerShell rules also fired multiple times during the respective attack. So this is real working detection. Everyone has like everyone of this alert came from a real Sysmon event captured through the compromise host. So now move on to my next slide, the lessons I learned. So one, the first is like the attack are fast. The original incident took 32 minutes. My automation just took like a minute. There is no time for human driven to like response to the automation is mandatory. The behavioral detection beats the surface detection rules that target attackers must do like XP underscore that services and all. Then moving to the third, like sysmon is very essential, and the fourth is like iteration is like very required because several of my rules needed tuning before they need fired correctly. And that's my whole project. Thank you so much. To summarize, I reproduced the real world attack, targeting rules, everything. And thank you so much for watching. I'm happy to answer any questions if you have it. Have a good day.